Well, hello everybody. Welcome to this lesson on all about the weather. My name is David Lawrence. I'm a meteorologist at the National Weather Service in La Crosse, Wisconsin, and I'm here today to talk to you all about the weather, different types of weather that we can get, how the weather develops, and how meteorologists can measure that weather and also report it to you to let you know when the weather could be particularly bad, which does happen from time to time. A meteorologist is someone who studies the weather routinely. We are here 24 hours a day at the National Weather Service. We always have at least two people on duty to monitor the weather. That means that while you're sleeping, or maybe it's Christmas Day or any particular day of the year, we have at least two meteorologists here 24 hours a day to monitor the weather and give you the latest forecasts and warnings that we need to do. We have 23 staff members here at the National Weather Service, and some of them also serve other roles besides forecasting the weather. We have lots of computers to take care of, and we have lots of other equipment, which I'll show you some of here in just a little bit. So what are the different types of weather? I mean, there's a lot of stuff. Sunny days, some of you might like thunderstorms, right? Some of you like snowy weather, especially maybe when it gets you out of school. There are all different types of weather that can occur, especially here where we live in the upper Midwest across Wisconsin, Minnesota, and Iowa, where there's all different types of weather that can develop and really does develop throughout the year. So how do we get weather to develop? Well, we need two things in particular. One, we need the sun. Why do we need the sun? I'll get to that here in just a minute. The second thing we need, it's all around you. You can't really see it in the air, but you certainly can see it in the rivers, the lakes, the streams. It's water. In this case, I'm talking about water vapor. Vapor is a gas in the air. The air that surrounds us is filled with water vapor. And when you combine heat from the sun and water vapor, we get something that's known as the water cycle. In other words, we get things like evaporation and precipitation. You may have heard these terms. A continuous cycle of water that loops around the earth and provides us with all different types of weather. Now, as I show you this animation on your screen here, you'll notice that this is the average temperature across the world, and you'll also notice that it sort of moves up and down depending on the time of the year. Some months are very warm across portions of the world, while other months are very cold. And it is that imbalance in the temperatures that gives us weather. In other words, temperatures are never the same at any given location across the earth. If I go north right now, it's a lot colder. If I come south, it's a lot warmer. And the difference in those temperatures is what drives the majority of the weather that occurs across the world. And it's also the reason that I have a job as a meteorologist. Now, here at the National Weather Service, we use a whole lot of different types of tools to measure the weather. One of the most important that we measure, and if any of you have ever driven by our office up here near Hickson Forest in the Hickson Trail System, you've seen the big white thing that looks like a giant golf ball. That is our weather radar. And radar is a great tool that allows us to see inside of thunderstorms and snow showers and all types of precipitation that's occurring out there. And the way it works is pretty simple. It sends out a pulse of energy, a invisible radio wave. If that energy bounces off something, it comes back to our radar and allows us to see, hey, how big is that something that I just hit? And believe it or not, we don't just hit precipitation. Sometimes we'll hit crazy things like birds. Some of that energy will bounce back to us. Any of you that live along the Mississippi River, you may have seen some mayfly hatches over the years. We can see those on radar. And occasionally, even on very calm nights, we can actually see things like interstates because some of that energy bounces off of cars and will come back to the radar. But it's a very important tool that allows us to see inside of thunderstorms. And what you're seeing on your screen right here is a loop of a tornado, which we'll talk about here in a little bit. This is a radar depiction of a tornado. We're looking at a lot of different types of parameters here, so don't get too confused. But I want you to notice on the upper right portion of that 4-panel, you'll see reds and greens close together. And that is where we have a circulation, in other words, rotating air that's developed in the atmosphere. And that is an indication oftentimes that we have a tornado that's developed. In this case, there was a tornado that we were able to see on radar. Our job at the National Weather Service is to use these tools like radar and other ones I'll mention here in a minute to be able to put out really great warnings to let you know when the weather's bad so that you can take precautions to keep yourself safe. Another thing that we use frequently is weather satellites. Radar sits on the ground, right? And we can see kind of in a general direction of about 240 miles around where the radar is centered. However, satellites sit way up in space. In fact, they're somewhere between 15 to 25,000 miles above the surface of the earth. And that allows us to look down on the earth and really get a picture of what's happening all around the world at once. A great example here, look on your screen, you will see lots of swirls. Can you pick out those swirls? Those are areas of low pressure. In other words, stormy weather that's developed across the country. And I can actually count 3 on my screen during this particular satellite image. So it's a great tool that allows us to see all across the world and measure different things like clouds and temperatures of clouds and how much moisture is in those clouds. And we use this on a daily basis here when forecasting the weather. Here's a loop of satellites. So it's not just a single picture. We can put a lot of pictures together and make a loop. And it allows us to see all different types of storm systems moving across not only the United States, but the whole world. If you look on your screen, take a minute. Can you pick out a couple of different storm systems? I count 1, 2, 3, at least 3 big ones, maybe a 4th one here at the end, and maybe some smaller ones thrown in there as well. Look for lots of swirling motion in the clouds, and that is oftentimes an indicator of a storm that has developed. One of the things that we also use to measure the weather is river gauges. We forecast not only the weather, but how much water is going to move down the rivers. Maybe we had a lot of rain that occurred one night, and now we have to figure out where all that water is going to go. Maybe some of you over the last several years have experienced some flooding close to your house, and hopefully not in your house, but maybe you have. We monitor these river gauges and really use them to be able to predict what's going to happen by letting us see what's going on ahead of the stream. In other words, if I move up the river, I can see how much water is coming down that particular river or stream and be able to give you the best warning to let you know how much water you can expect to move down a particular river or stream. Now, when it comes to weather, we have all different types here across the upper Midwest. We just came out of winter as I'm recording this in May, right? We have lots of snow and we have some ice sometimes, and sometimes it gets you out of school and you're really happy with us. Sometimes it doesn't. And you're like, I wish we had more snow. But we get lots of winter weather around here. And I'm going to talk a little bit about some of the tools that we are used to measure the weather. And believe it or not, this is the most simple tool that you probably even have laying around your house. To measure the snow, guess what? We just use a ruler. Do you have a ruler in your house? You can help us measure snow. And in fact, you can call us at the National Weather Service 24 hours a day and tell us how much snow you measured on your ruler. That is the simplest measuring tool that we have here. Stick it in the snow, tell me how much fell, and you give us a great report, and we really appreciate that. When it comes to measuring rainfall, we use something called a rain gauge. It's a cylinder, just like the one you'll see on your screen here. It has a funnel in the top, so when the rain falls, it gets trapped in that funnel and that drops into the cylinder. And if you look really closely, you'll see some numbers inside that rain gauge. Those are amounts of rainfall. It measures in tenths of an inch or 1/100ths of an inch, depending on the type of rain gauge that you're using. And it's that simple as well. Water falls in, someone goes out, a human person goes out and actually measures exactly how much water has fallen in there, and they let us know. That helps us to forecast not only how much precipitation has fallen, now we know that, but maybe will there be flooding that could develop because of that? Or maybe when it melts, where is all that water going to go? Maybe you just planted your garden and you really want to know how much rain fell so that those plants can grow. This rain gauge will tell you exactly that. How about temperature? How many of you like really cold temperatures? Maybe some of you like really hot temperatures, right? We use something called a thermometer. There are different types of thermometers. I actually have one here in my hand. This is an old school mercury thermometer. It actually uses mercury, which can be a dangerous substance, but it's contained in here, so we don't have to worry about that. But we use different types of thermometers to measure the temperature. Some are analog, like this. This is old school technology. It's been around for a very long time, and it still works great. Some of you may have a thermometer like you see on the screen here. Maybe it's mounted off of your deck or something like that, and occasionally you look at it to see what the temperature is. We also have digital thermometers that use electronics to measure temperatures. There's a lot of those out there right now. But overall, those are still thermometers and the number one tool that we use to measure temperature. Temperature can be measured in degrees Fahrenheit, which is what most of the United States uses, or also in degrees Celsius, which is a lot of what the rest of the world uses. But we also use Celsius here at the National Weather Service sometimes to do our forecasts. Air pressure is measured using a barometer. Now, believe it or not, air has weight. Look around you right now. Can you feel the weight pushing down on you? Probably not, because you're born with it. You know exactly, your body knows exactly how much pressure it should have pushing down on it. But believe it or not, for every square inch, that's 1 inch by 1 inch, little tiny square, there's about 14 to 15 pounds of pressure pushing down on you right now. That means if you were to lay down on the floor, the amount of weight from the air pushing down on you is somewhere in the vicinity of how much your school bus weighs. Can you picture that? A school bus worth of air sitting on you right now. The weight of air is very heavy. And it does change depending on whether we have high pressure systems where the weight is really pushing down on us, or lower pressure systems where there's a little bit less weight and more stormy weather. But the reason that you can't feel that air pressure, again, your body is built for it. It's designed and you're used to that particular weight pushing down on you on a routine basis. But air pressure is a very cool thing. It allows us to do a lot of neat things. Now, however, I have all these really cool tools. What if I want to measure the entire atmosphere? Well, I can do that through satellites to some degree. I just showed you that earlier. But there's one other tool that we have here at the National Weather Service that we launch twice a day. And it's not just here in the United States. We launch these all around the world. It's called a weather balloon. Some of you may have seen weather balloons before. I actually brought along one today. Might be kind of hard to see. I'm going to back up here. This is an extremely, extremely stretchy. You can't even see me now. It's a huge, huge balloon that we inflate. You see one inflated there in the photo. We fill this with hydrogen or helium because that's a lighter than air gas. In other words, it will rise, just like maybe you have a party balloon or something like that at a birthday party. And this balloon gets very large. And to the back of that, we tie this instrument. And this is called a radiosonde. And what this does is it allows us to measure temperature, air pressure, and wind speed and direction, not only here at the surface of the Earth, where hopefully all of you live. I know I live at the surface of the Earth. But it allows us to measure all these same variables way up into the atmosphere. So I can measure temperature not only here, but maybe 10,000 or 20,000 or 50,000 feet above my head right now, simply by sending up this weather balloon. And this is a very valuable tool that the National Weather Service uses in order to help us get a picture of what's going on, not only here, but way up in the atmosphere where all of our weather starts. All of our precipitation, rain, snow, whatever it is, starts up there and then ends up down here. So we use these tools to measure what's going on above us. Let's get back to winter weather, tying it all together. If we have all of these variables measured, we can really get a sense for what type of weather is going to occur. If it's cold and we have enough moisture and the temperatures are cold enough, measuring by thermometers and satellites to know how much moisture, we can get things like very hazardous winter weather. The video you just saw on your screen there is really kind of scary. Snow is great. A lot of you, I love to play in the snow. I hope you do as well. But when you're driving and when you start to drive, it can be very, very dangerous. It can be very slippery and hazardous when people drive too fast in the winter. So it's our job to tell people when it's going to snow. So hopefully things like that don't happen. Now, thankfully, in the video you saw, nobody was hurt. But it really goes to show you, you have to slow down, not only when you're driving, but when you're walking in winter weather. Ice and snow are very, very slippery. So we always say ice and snow, take it slow. Walk carefully and drive carefully. Flooding, another thing that develops. Too much moisture. If it's very warm, and we measured that with the thermometer, and we get big thunderstorms with lots of moisture, and they dump too much rain too fast, we can get flooding. In other words, water ends up where water should not belong. In this case, you see a car that drove into the water, which we really can't stress enough. That is a bad idea. I don't know about you, but I don't like to particularly get very wet when I'm riding in a car. So anytime you see floodwaters, this is a great reminder. Remember, turn around, don't drown. That sounds a little harsh. We know that. But we don't want you to get hurt by floodwaters. Flooding can be very dangerous, and it can sweep people away because floodwaters move very quickly. So whenever you see floodwaters, always, always, always walk away from them. Don't get close to them, and you will be perfectly fine. Here's a video of someone that chose, unfortunately, to drive into a flood, proving that water is a very powerful force. If you don't believe me, just look at the Grand Canyon, which was carved out by lots of water over a long period of time. That water carved through rock. This particular water is strong enough to move cars. So if water can carve through rock, it pretty much can sweep away anything that it wants to. This is a really amazing video. I want you to watch as this car is driving. This is a flash flood that occurred in the mountains. And look at this humongous boulder that came crashing down out of the mountains because of too much water. It's a huge rock, and thankfully it missed all the cars. Nobody was hurt in this. But it's really, really an amazing portrayal of how much water, how much force water has. It can move things like giant boulders. So again, flooding, very dangerous. We encourage you, please, please, please never get near floodwaters. And we appreciate that. Lightning. How many of you like lightning? I think lightning is fascinating. Really, really it is. The one thing about lightning, it is very unpredictable. We do not know where lightning is going to strike at any particular location. We can measure lightning using satellites, which I talked about earlier, but at the same time, we can't predict exactly where it's going to strike. So if you can ever hear thunder, if you're ever outside and you hear thunder, please go inside, because if you can hear thunder, you are close enough to be struck by lightning, and we don't want that for sure. Lightning takes about 5 seconds between the time that you see the flash and you hear the rumble of thunder. So if you ever see lightning, and hopefully you're inside where you're safe, count to 5. And if you hear the rumbles of thunder right at 5, that's about 1 mile away. For every 5 seconds you count, it's going to be about 1 mile. So you can actually calculate how far away the lightning was from you, depending on how long it takes you to hear the rumble of thunder. I love this video because it's a very slow motion video of a lightning strike, right? Lightning has a lot of power in it in an instant. It's a very dangerous thing if you're outside, especially near tall objects, but it really shows you just how massive a particular lightning strike can be. Another example here, and this one has a little bit of sound, but I want you to watch that. Let's see if we can go back here and watch this again in slow motion. This is lightning that actually hit a power pole, like a pole that held onto power lines. And I want you to see the pieces of wood that exploded out of that. Again, lightning is a very powerful force, very dangerous. When lightning roars, go indoors. We want you to be safe. And the best way that you can be safe is when you hear thunder or you see lightning, get inside, get away from windows. And here's a fun fact. If you cannot get inside a building, you know where the second best place for you to be is? It's actually in a vehicle, because lightning can hit a vehicle. It will travel safely around the frame of that vehicle into the ground, and you will be perfectly fine. In fact, if you look on the screen right now, you will see an example of lightning that hit the windshield of a car that people were inside, and they were completely fine. So when when thunder roars, go indoors, be safe around lightning always, please. Hail is a very interesting thing as well that can develop from thunderstorms. It's gigantic pieces of ice sometimes that fall out of a cloud in the middle of summer. Some of you may have seen hail over the years. Sometimes it's very big, sometimes it's very small. La Crosse, in fact, back in 2011, had hail about the size of baseballs. So huge, picture a baseball, but it's hail, it's ice falling out of the sky. That worked across the city and did a lot of damage, as you can imagine. A giant piece of ice, but millions of them falling from the sky all at once. Hail forms inside of very strong thunderstorms, and it can take all sorts of different shapes. Oftentimes it is circular, but sometimes, look on the photo, the bottom left there, sometimes it looks like little stars. It can look like all sorts of different funky shapes at times. And here's an example of what large hail looks like. And I hope none of you ever have to see this in person, because large hail is really mesmerizing to watch, but it's very dangerous and it's very destructive as well. But you notice that these giant balls of ice about the size of a baseball, when they hit the ground, they actually bounce because they're falling so fast from the sky. Winds in a thunderstorm. Winds in general can be very strong sometimes, but especially in thunderstorms. Here's an example of someone that's trying to wrangle a balloon, a giant balloon. Now, this isn't a weather balloon, but it's a hot air balloon. And they're getting a lot of resistance because of wind. Wind is a very powerful force. In fact, it's so strong that we use it to generate electricity in some parts of the country. But you can see the force of wind here can actually pick up pretty much anything in its path and distribute it wherever it wants to place it. So anytime you can hear thunder, again, get inside, get away from windows, things like that, because not only do thunderstorms have thunder and lightning, sometimes they can have hail. Sometimes they can also have large damaging hail, and they can also have very strong winds. And sometimes, I know some of you might have been waiting for this, sometimes they can have tornadoes in them. The tornado is nothing more than a tube of air that's connected to a thunderstorm, and that tube of air is in contact with the ground, and it usually will cause damage of some sort. Tornadoes are very dangerous. There's no way around it. If you hear a warning issued for your area for a tornado, you need to seek shelter immediately. Don't run outside and look to see if you can find the tornado. Seek shelter immediately. There are many different types of tornadoes. We classify them from weak to strong. We have a lot of weak tornadoes around here, but we have had some very strong ones in the past as well. You can see weak tornadoes generally are smaller, generally don't do as much damage, but certainly you still need to take precautions. Seek shelter safely whenever there's a tornado warning. If you want an example that's close to home, hopefully you can see the video here. This is from 2011. This is from Sparta, Wisconsin. You can see a tornado that's occurring. Now, this was rated an EF1 with winds a little over 100 miles per hour, but you see that tube of air in contact with the ground. And if you look closely, you might even see some debris. In other words, pieces of trees or sometimes pieces of buildings that are actually being lifted into that tornado. A very dangerous situation. Thankfully, no one was hurt here. We had tornado warnings out. We were warning the people, which is what we do at the National Weather Service. By doing that, they were able to take safe shelter and be very safe throughout the entire storm that occurred. Strong tornadoes are often very, very large, and you can see some pictures on the screen here. They can be very destructive, very dangerous. But again, I want to caution or remind you that if you hear a tornado warning issued, you definitely want to seek shelter. Here's kind of a crazy video real quick, too, of a tornado. You'll see this white car coming across the screen here, and a tornado actually develops and moves over this car. It's a very small tornado, but look how much stuff it's picking up. It's picking up leaves and debris, and it actually pulled this person out of their vehicle. You see this person sitting on the sidewalk there on the bottom right, and you can see the tornado continues to move on. Just as quickly as it was there, it moved on, and it caused a lot of damage. Again, thankfully and amazingly, no one was hurt in this particular storm. But tornadoes, again, can be very, very dangerous. We want to encourage you, always take them seriously. So for tornado safety, this is the easiest one. You always want to find safe shelter. Just like any thunderstorm, just like lightning, find safe shelter. Get inside if at all possible. Listen for sirens or warnings. You may have sirens in your town going off telling you that there is a possible tornado coming. If you have a basement, we encourage you to get in the basement or underneath stairs, something like that, someplace that will protect you the most. And I don't want to scare you. That's not the point of this. But severe weather does happen from time to time. And you can rest easy at night knowing that us here at the National Weather Service, again, we're here 24 hours a day to keep you safe in your home. So if there's bad weather coming, we're going to alert you, and we're going to alert your parents and people that are around you so that they can help you to take precautions and protect yourself. You may have also practiced this in school over the past several years where you had a tornado safety drill. Maybe you got into the hallways and you got down and you crouched down as much as you possibly could. So this is just another way that you can stay safe. This is a great choice. You can also do this at home as well. And with that said, I want to thank you really quickly for your time today. I didn't want this to go too long, but I hope you learned a little something about weather, how we measure weather, and the different types of severe weather that can occur around here. If you have any questions, I'd be more than happy to answer them. You can always reach out to me, david.lawrence@noaa.gov. Feel free to email me or ask your teacher. I'm sure that he or she could get in touch with me, and I would be more than happy to answer your questions. Thank you so much for your time. I hope you enjoyed this. Have a great day.